Hello everyone, how are we? Okay, this is 2.6, proving geometric relationships. Okay, so still proving, like I said, we're going to be doing a lot of proving from here on out in geometry. Notice our objective is still about writing two-column proofs, but today in this section we're going to be focusing on congruent angles and theorems and their theorems. Okay, so oh boy, what the heck is a theorem? Oh my goodness, let's talk about that first. So a theorem is a conjecture or statement that you prove to be true. Some statement, some conjecture, remember, like after we have observed and we see patterns, that's when we make a conjecture. We need to then prove it, okay? So something that we prove is true. We don't just prove it for fun. We have to actually prove it's true. And we prove it to be true by writing a proof, okay? And that's how we prove theorems. You have to write a proof. Notice theorems cannot be used as a reason in a proof. So I can't, I'm about to show you a whole bunch of theorems. We can't use them as one of our reasons. You know, in the two-column proof on the right side, I can't use a theorem to prove as a reason. Remember the difference between postulate and theorem. Remember, a postulate is something we accept to be true without a proof. Okay? Theorems need to be proved by writing a proof. Okay? Let's talk about some major theorems that we're going to not memorize, but the more we use them, the more ingrained they will be in our brains and easier to prove things if we have them in our heads. So let me go ahead and talk to you about them. They're also on a PDF saved in the file in this weekly folder, so you can print that out if you want to, or write this down. So theorem, I have a right angles congruence theorem. Basically says that right angles are congruent, which makes sense, right? 90 degrees, 90 degrees, this one's easy. Right angles congruence. Right angles are congruent. The next one says congruent supplements theorem. Okay, this one says if two angles are supplements of the same angle, then the two angles are congruent. So here's a nice example. If 1 and 3 are supplements, and look, they're on 180, and then 1, I'm telling you as well, 1 and 2 are supplements. Notice they would fit as a linear pair too. Then 2 and 3 are congruent. Makes sense? If 1 and 3 are supplements and 1 and 2 are supplements, well, that means 2 and 3 must be equal. 2 and 3 are congruent. Very similarly is the congruent complements. I'm not going to talk about this one in detail because it's the same thing just for complementary angles. 1 and 2 are complements, 1 and 3 are complements. That means 2 and 3 are congruent. Okay, the next one, oh wait, this one's my favorite. I probably have a lot of favorites at this point, but I love this one. It's so nice, so simple. Vertical angles congruent. Congruence theorem, vertical angles are congruent. That's all this says. If I have vertical angles, they're congruent. You can't get much simpler than that, right? Angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4, okay? Vertical angles are congruent. Remember that phrase. And then the last one is a postulate that I just want to remind us of. It's called the linear pair postulate. If two angles form a linear pair, then they are supplementary. We also kind of talked about this in the definition of linear pair back in chapter 1, so it's actually also a postulate. If two angles form a linear pair, then they are supplementary. Okay, so we have to really get used to these theorems because we are going to use them in proofs. Okay, the proofs that we're going to talk about too in this video, they are geometric proofs. Okay, and these are pretty fun. I do like them. Well, what don't I like, right, guys? So I always have what's given and what I need to prove. That's what we always start off with. And let's take a look at this. They are telling us, and I always label, they're telling us that angle 1 and angle 3 are vertical angles. Okay, and they want me to prove, they want me to prove that they're congruent. Okay, you should already be thinking of some things that you know why they're congruent. Okay, so let's start here. What we are doing and ultimately is proving that vertical angle theorem, that last one I just talked about. Proving how I know. Why can I say that they're congruent? That's what this proof is all about. always start with the given statement, right? Angle 1 and angle 3 are vertical angles, and that was given to me. The next statement is that angle 1 and angle 2 are supplementary angles. We can see that, right? Angle 1 and angle 2 are supplementary. I can also say that 2 and 3 are supplementary. And I can say that because of their linear pair. They're a linear pair and because of the linear pair postulate. Okay? I'm on a line. 2 angles are a linear pair. They're also supplementary. So now we have to fill in the blank here. The reason for this next step is the definition of supplementary angles. Well, what's the definition of supplementary angles? That when I add the 2 angles together, they equal 180. Okay, and why it's helpful for me to say that, I just took angle 1 and angle 2, add to 180, 2 and 3 add to 180. Why I can say that is because now look what I did. Measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. How could I say that? That's what I need to fill in the blank here. How can I do that? Substitution, right? They both equal 180, so let's set them equal to each other using that substitution property. And now, look, I got rid of the measure of angle 2 by subtraction. I have measure of angle 1 equals measure of angle 3. When 2 angles are equal, we can say they are congruent, which is what I wanted to prove all along. Definition of congruent angles. Okay, so for these guys, you're filling in the blank. You really have to become familiar with these definitions, the properties, the postulates, and make sense of the statements. Okay, so let's take a look at another example like this. Here we're going to prove the congruent supplements theorem. So given what was in that chart, given that 1 and 3 are supplementary angles, that 2 and 3 are supplementary angles, prove that these 2 angles are congruent. Okay, I'm going to start with my given. Always start with my given. Notice my second step. I jump to supplementary angles, right? Notice that. Notice that I go from 1 to 2 because of what I said in the first step. I'm basically just using the definition of supplementary angles. That's my reason. 1 plus 3 gives me 180. 2 plus 3 gives me 180. Definition of supplementary angles. My third statement, I have to fill in the blank here. What did I do? Why could I do this? Substitution, right? They both equal 180, so I could set them equal to each other. That's called substitution. Fourth, subtraction property was my reason, so what did I do? Subtracted the measure of angle 3 from both sides, because that's what they both sides have in common. So I'll be left with the measure of angle 1 equals the measure of angle 2. Oh boy, look what I was trying to prove all along. Once I have something equal, we can say that they are congruent. Definition of congruent angles. Cool? We'll get the hang of it, guys. I'm sure you're already feeling a little bit more confident than you did the first day we started proofs. Okay, baby steps, we got this. But ultimately, guys, I have another favorite. I keep on talking about favorites. My favorite thing about theorems is that we can use them to solve problems. And that's why we love math. We love math because we can solve problems and numbers. So that's why I love tying in geometry proofs to math, because it allows us to solve problems using the theorems we've discussed in this section to solve the problems below. Okay, and we are going to solve this first one. Find x. Well, I wasn't given too much, but what I need to know, what I need to notice, I need to notice that this angle that they told me the measure of was 3x, and this angle, 2x plus 40, what do I know about them? What do I notice? I notice that they are vertical angles. And what do I know about vertical angles? They are congruent, which tells me what type of equation am I going to write? They are congruent. Well, 3x plus, 3x equals 2x plus 40, because I know vertical angles are congruent. So let's set those 2 angles equal to each other and solve. I'll subtract 2x from both sides, so I'll have x equals 40. Man, I love geometry. There's my x. All right, what about this one? Find x and y. Oh boy. take a look at that diagram, soak it all in. What information, what theorem can I apply to this diagram? A few, actually. You can take a look at how I have a linear pair, right? I have a linear pair, so I have supplementary angles right here, or supplementary angles right here. That isn't going to help me too much because I have two variables, though. Notice I don't want to do much with this angle because it has two variables. So where can I write an equation that has only one variable in it? And it's going to be those beautiful vertical angles again. I love vertical angles. Vertical angles are equal. Notice the pink and the blue. Okay, we can write that equation. 5x plus 20 equals, because that angle is congruent to 3x plus 40. Because vertical angles are congruent. That theorem. I love that theorem. And now we can solve this for x. So I'm going to subtract 3x from both sides. I'm going to say 2x plus 20 equals 40. Subtract 20 from both sides. 2x equals 20. And divide both sides by 2. X equals 10. Wonderful. But wait a second. Wait a second. I need to find y. I need to find y also. So how am I going to do that? Now let's tie in that linear pair, right? Let's tie in that supplementary theorem, okay? Where we can say that linear pair postulate. That's what we're going to tie in here. I'm going to say, using this right here, there's my linear pair. 5x plus 20 plus x plus y equals 180. Because of the linear pair postulate. So this is the linear pair postulate. We'll say that. And over here was the vertical angles congruence theorem. Whoa. Okay. Solve this next equation. Let's combine like terms. 6x plus 20 plus y equals 180. Well, wait a second. I know x equals 10. So 6 times 10 is going to give me 60 plus 20 plus y equals 180. Now we can solve this easily for y. I'll combine like terms. Gives me 80 plus y equals 180. Subtract 80 from both sides. Y equals 100. Okay, guys. So this is where I really love my geometry, is when we get to use this, do this kind of math. Taking the facts that we know about theorems, assuming things with the postulates, so I can solve problems like this. Okay, awesome work, you guys. I hope you're excited. We are just getting started. We will be practicing this tons, not to worry. Bring me any questions, okay? You guys rock.